Let's see how to draw a structural formula for C4H10. C4H10 is named as butane because there are 4 carbon atoms, and according to the prefix rule, the name is butane. Now we can draw different types of structural formulas for this C4H10 molecule. So if we draw the expanded structural formula, it will look like this. So you just draw 4 carbon atoms and place hydrogen atoms, making sure each carbon atom contains 4 bonds. For example, this carbon atom contains 4 bonds, 1, 2, 3, 4, and this one also has 4 bonds, 1, 2, 3, 4. This one has 4, 1, 2, 3, 4. And this one has 4, 1, 2, 3, 4. That's how you make sure there are 4 bonds around each carbon atom. Now, once you draw the structural formula or expanded structural formula, you can convert it into line angle formulas like this. So you just have to visualize the carbons in these corners and ends. So you can draw this line angle formula in 2 different ways. Both are correct and both of them shows the same molecule, C4H10. Now, if you draw condensed structural formulas, you can draw multiple formulas as you see here. Let me drag this screen a little bit. Okay. Now, the condensed structural formulas that you see here are all correct. It shows the same molecule, but you can basically see like the main 4 carbon chain has been like bended to make different forms. But all of those formulas are the same for the same molecule. So you can practice this for a different formula like C5H12 as well. We will do more examples in future slides. Okay, the next topic is the cycloalkanes. So what is a cycloalkane? So these are also contains carbon-hydrogen bonds and carbon-carbon single bonds. Only difference is they are cyclic compounds. So the cycloalkane with the smallest number of carbon atoms is the cyclopropane with 3 carbon atoms. So that we call that as cyclopropane. And in this slide, you can see the cycloalkanes are shown in 3 different ways. The ball and stick model, it is a 3-dimensional model that you can see the atoms as balls and the bonds as sticks. And the condensed structural formula that we already know, we can condense the CH3s and CH2s and the line angle formula. We'll see one by one. So for cyclopropane, you can see the ball and stick model is showing here, so you can visualize how it looks like in 3-dimensional way. So there are 3 carbon atoms. The carbon atoms are shown with the black color balls, and the hydrogen atoms are shown with the white balls or gray balls. Now, if you count the number of bonds around each carbon atom, it still shows that there are 4 bonds. That's the main rule. So we can convert this ball and stick model to a condensed structural formula to show the same uh, the formula, the same formula for cyclopropane. Um, Now here in cyclic compounds, one difference that you see is you don't see CH3 CH3s in the cyclic form. Okay, instead you will see CH2s because there is no way for a carbon atom in the cycle to make to bond with three hydrogen atoms because each carbon atom is bonded to two other carbon atoms. So it has only two spaces to form bonds with hydrogens. So that's why you see CH2s um, in the cycles. So this is true for any cyclic compound like for cyclopropane, cyclobutane, cyclopentane, and cyclohexane. Now we'll see one by one, and the cyclic compound with four carbon atoms is called as the cyclobutane, and the cyclic compound with 5 carbons is cyclopentane, and cyclic compound with 6 carbon atoms is cyclohexane. So these names are very important. So these are according to the IUPAC naming, and you have to memorize these names. Okay, so if you look at the line angle formula, um, so you just convert this into a lines and angles. So you can convert the cyclopropane condensed structural formula just to a triangle, and each angle represents CH2s. And in cyclobutanes, you can see four corners showing four CH2s. And in cyclopentane, you can see 5 corners showing 5 CH2s. And in cyclohexane, you can see 6 corners representing 6 CH2s. So these are the things that you need to know about cycloalkanes. We will do more examples with substituents in the future slides. Okay, now pause the video and answer to this question, and then come back and check your answers. Okay, give the IUPAC name for each of the following compounds. So A contains 1, 2, 3, 4, 5, 6, 7, 8. So there should be 8 carbon atoms in places of these numbers. And as you see, there are no double bonds or triple bonds. So this is an alkane. Since there are 8 atoms, you need to check the prefix for A. So that is oct. So the prefix is oct and the name ends with ane, so it is octane. So the part B, it's a cyclic compound and there are 1, 2, 3, 4, 5 corners. So the cyclic compound with 5 carbon atoms is, remember when it comes to IUPAC naming, for any cyclic compound, your name starts with the prefix cyclo. Okay? Cyclopentane. Please don't forget cyclo. If you just write it as pentane, it will be the linear molecule. So cyclo makes it unique for the cyclic compounds. So those are the answers. Okay. And the learning check 2. Now pause the video and answer the question. Then come back and check your answer. Okay, let's check our answers. A. It is a linear molecule with 4 carbon atoms. So the prefix is but, and it's an alkane, so it's butane. Part B is cyclopropane, and C, it has 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons containing alkane is octane. And D has 1, 2, 3, 4, 5, 6. 6 carbon containing alkane. For 6, if it is a linear compound, we say it is hexane, right? If it is linear. But since it's a cyclic compound, we add this prefix cyclo in front of hexane, so it is cyclohexane. So that's how you figure out the naming of different alkanes. Okay, now regarding structural isomers. So what is a structural isomer? This is a new term that comes when it comes for these organic compounds. So the structural isomers are the compounds containing the same molecular formula but with different arrangement of atoms. So when it comes for these structural formulas for a given molecular formula. So what is the difference between the molecular formula versus structural formula? So if I take C4H10 as an example, C4H10 is the molecular formula. You just show the number of atoms in front of the atom symbol. No bonds are showing there. So this is the molecular formula. If I ask you to draw the structures, condensed structural formulas or expanded structural formulas for the C4H10, there are two different ways that you can draw the structures. And so these are the two different ways that you can draw. First, you can draw it as a simple butane like this. CH3, CH2, CH2, and CH3. So the number of carbon atoms is 4 and the number of hydrogen atoms here is 10. So it goes along with this molecular formula. And what is this molecule? So you can just take one carbon atom and attach it to the second carbon. And as long as the rule number 1 satisfies, each carbon atom is bonded to 4 different atoms. And if the total number of atoms satisfies to this molecular formula, then this structure is correct. Right? So both of those are satisfied. Now you can see each carbon atom contains 4 bonds. And the total number of carbon and hydrogen atoms is go along with the C4H10 molecular formula. So this is a valid structure. So, but if I have to name the molecules, the name of these two molecules are different. We will come to that part later regarding naming isomers. So for now, just remember these two types of different structures are called structural isomers because their arrangement of atoms is different. The first one is a straight chain and the second one is a branched chain because the CH3 is considered as a branch. And you can still draw these the line angle structure for this just like that because this is CH3 and CH3 here, CH3 here, and for this carbon there's only one hydrogen attached. Okay, so those are two structural isomers.